Welcome to the .NET Way. You're watching episode 14 of our .NET Core interview series. Today we are talking about the one thing that separates clean, professional projects from fragile, legacy nightmares: testing. Specifically, unit testing versus integration testing in ASP.NET Core. Joining us to share how she tests her code and completely avoids breaking things in production is our architecture expert, Arohi. Welcome back!
Thanks for having me. Testing is my favorite topic. Writing code is easy, but writing code that you can confidently change 6 months later, that requires good tests.
Let's start simple for the beginners tuning in. Arohi, what exactly is a unit test?
A unit test verifies the smallest testable part of an application, usually a single method or class, in complete isolation. As you can see on the screen, the main benefits are that they run in milliseconds, they are highly repeatable, and they catch logic bugs early in the development cycle. A good suite of unit tests acts as living documentation for how your code is actually supposed to behave.
How would you explain the fundamental difference between a unit test and an integration test?
It comes down to dependencies. In a unit test, we isolate and test exactly one component. If that component talks to a database, we don't use a real database. We use a fake or mocked version of it. In an integration test, we want to see how things work together. We test the controller, the service, and an actual test database all at the same time to ensure the wiring between them is correct. Both are important, but they serve entirely different purposes.
There are a few different testing frameworks in the .NET ecosystem. What does your preferred unit testing stack look like?
My standard stack consists of three main libraries. I use xUnit as the actual testing framework to write and run the tests. I use MOQ to create fake versions of my interfaces and dependencies. And finally, I use Fluent Assertions because it allows me to write verification statements in plain, readable English. It's a very powerful combination for any .NET Core project.
Can you walk us through what a basic unit test actually looks like for a standard service method?
Sure. Let's look at the example on the screen for a method that gets a user by their ID. We decorate the test method with the fact attribute so xUnit knows it's a test. First, we create a mock version of the user repository, and we instruct it to return a specific dummy user when the ID of one is requested. We pass that fake repository into our user service. Then, we call the method we actually want to test. Finally, we assert that the result is not null and that the ID matches what we expected.
I noticed you had comments in that code saying arrange, act, and assert. What is that?
That is the AAA pattern, which stands for arrange, act, and assert. It is the industry standard way to structure a unit test. Arrange is where you set up your mock objects and variables. Act is where you execute the exact method you are testing, and it should usually only be one line of code. Assert is where you verify that the method returned the correct output or threw the correct exception. Keeping this structure makes tests incredibly easy to read.
You mentioned using MOQ to create fake repositories. How do you actually isolate a class from its dependencies so it can be mocked?
You can only mock what you have abstracted. I rely heavily on interfaces and dependency injection. If my user service creates a database connection directly using the new keyword, I cannot mock it. But if my user service asks for an iUser repository interface in its constructor, then during testing, I can easily use MOQ to inject a fake implementation. This ensures I am only testing the business logic of the service, not the external database.
What if you have a method like a discount calculator and you want to test it against 10 different pricing scenarios? Do you write 10 different test methods?
Not at all. That would be a maintenance nightmare. That is where data-driven tests come in. In xUnit, instead of the fact attribute, we use the theory attribute combined with inline data. As you can see on the screen, we pass our different scenarios, like the initial price, the discount amount, and the expected total directly into the test method as parameters. The test runner will automatically run this single block of code 3 separate times for our 3 different scenarios.
Let's shift to integration testing. What's different about the setup when you want to test the whole pipeline?
Integration tests require a real server environment. In .NET Core, we use a special class called WebApplicationFactory. As shown on the screen, this class literally spins up a real in-memory test server using your application's actual program.cs file. It then provides us with an HTTP client that we can use to make real HTTP GET and POST requests to our API endpoints, just like a front-end application would.
If you're running a real integration test, what do you do about the database? You don't want tests deleting your real production data.
Exactly. In the past, developers used the Entity Framework in-memory database for testing. But that is now considered outdated because the in-memory provider doesn't behave exactly like a real SQL database. Today, the industry standard is to use a library called Testcontainers. It automatically spins up a lightweight Docker container running a real SQL server just for the duration of the test. Your API talks to this temporary database, and when the test is over, the Docker container is instantly destroyed.
Almost all modern .NET code is asynchronous. Is there anything special we need to do when unit testing async methods?
Yes, one major rule. Never use async void in your unit tests. If you use async void, the test runner cannot track the lifecycle of the thread, and the test might pass before the assertion even runs. As you can see on the screen, your test methods must always return an async task. Then you can safely use the await keyword inside the test, just like you would in production code.
How do you write a test to prove that your code properly throws an exception when something goes wrong?
In xUnit, we use the assert.throws or throws async methods. As shown in the snippet, we wrap the method call that we expect to fail inside a delegate function. Then, we tell our assertion library to execute that function, and we explicitly assert that it must throw or even verify that the error message contains the correct text. If the exception is not thrown, the test fails.
Here is a classic interview question. What is the difference between a mock, a stub, and a fake?
It's a great question. A stub is simply a dummy class that provides hard-coded answers to method calls so your test can run. A mock is much smarter. It allows you to verify behavior. With a mock, you can actually assert, did the service call the database's save method exactly one time? And a fake is a working implementation, but taking shortcuts, like an in-memory repository that uses a list instead of a real SQL database.
What if you have a complex helper method that is marked as internal? It isn't public, so your test project can't see it. How do you test it?
You should generally focus on testing the public API of a class. But if an internal method is highly complex and needs its own tests, you don't make it public just for testing. Instead, you use the internals visible to assembly attribute. As shown on screen, you add this to your main project file, specifying the exact name of your testing project. This grants your test project special VIP access to read and test internal classes and methods while keeping them hidden from the rest of the world.
In our last episode, we talked about logging. How do you write a unit test to verify that your service correctly logged a specific error message?
Testing ILogger is notoriously tricky because the standard log methods in .NET are actually static extension methods, which MOQ cannot mock directly. To test it, you have to use MOQ to intercept the underlying core log method of the underscore under interface. You verify that it was called with the correct log legal, like error or warning, and you inspect the internal formatter state to check if the correct message was written.
With all these tools available, how do you judge when to write a unit test versus an integration test?
It comes down to the test pyramid. I use unit tests for the vast majority of my business logic, calculations, and validations because they execute instantly. I use integration tests sparingly, only when I want to verify complete behaviors, like ensuring Entity Framework actually generates the correct SQL or that the API routing works. You don't need 100% of both. You just need a solid foundation of unit tests capped with a few critical integration tests.
What does your folder structure look like for a solution that has both types of tests?
I always keep them in completely separate projects. As you can see on the screen, inside my tests folder, I will have one project specifically named myapp.unittests and another named myapp.integrationtests. This is crucial because integration tests take a long time to run. By separating them, developers can run the fast unit tests locally every few minutes, and we can configure the build server to only run the slow integration tests when a pull request is created.
We hear the term TDD or test driven development all the time. Do you actually use TDD in the real world?
TDD is the practice of writing the failing test before you write the actual production code. It follows the red, green, refactor cycle. In the real world, I don't use strict TDD for every single line of code, like simple CRUD operations. However, if I am writing a complex algorithm, like calculating taxes or processing multi-tiered discounts, I absolutely use TDD. Writing the test first forces you to think strictly about the inputs and expected outputs, which results in much cleaner, bug-free logic.
Managers love to talk about code coverage. Should a team aim for 100% code coverage?
Code coverage tools analyze how many lines of your production code were executed during the test run. While it is a useful metric, aiming for 100% coverage is an anti-pattern. If you try to reach 100%, developers will start writing meaningless tests for simple properties and DTOs just to satisfy the metric. Instead, I aim for 80% coverage, focusing heavily on the complex domain logic and services. The core business rules must be covered. The standard boilerplate code does not.
How do you ensure developers don't forget to run these tests before deploying? Do you automate test execution?
Absolutely. Human memory is not a deployment strategy. I use GitHub Actions or Azure DevOps to automatically run the .NET test command on every single push or pull request. If even one unit test fails, the CI/CD pipeline crashes and the code is blocked from being merged into the main branch. This ensures we never break builds silently.
To wrap up, what are the most common mistakes you see developers make when writing tests?
The biggest mistake is writing flaky tests. Tests that pass sometimes and fail other times, usually because they rely on the current date, time, or an external API that might be down. The second mistake is writing tests that are too complicated. A unit test should have no conditional if statements and no for loops. And finally, ignoring edge cases. Testing the happy path is easy, but you must test what happens when the input is null, when the list is empty, or when the user doesn't have permission. Clean, meaningful tests save you hours of debugging in the long run.
That was a fantastic overview, Arohi. Testing truly separates solid professional developers from those who just write code and hope for the best. If you found this masterclass valuable, be sure to hit the like button, comment below with your favorite testing tool, and subscribe to the .NET Way. In episode 15, we'll see a real integration test example using Entity Framework Core, showing exactly how to run tests with actual data and database interactions. Thanks for watching, and we'll see you in the next episode.